You are welcome, students and viewers. In this video, we are going to have a lecture in Math 103, Trigonometry and Coordinate Geometry. Coordinate geometry. So, in today's lecture, we are going to treat trigonometric functions. Trigonometric functions. So consider a circle of a positive radius of a radius r greater than 0. That's a positive radius. Let P be a point with coordinate xy in the xy plane. So this is what we are saying. So this is what we are saying. This is P. Also, let OA be the x-axis. That is, A is a point on the x-axis. So, and also let the circle intersect the point A. So here is the point A. So let's have a circle like this. Okay, something like this. So let this point be A. So here is, so what we mean, the circle is centered O, and A is a point here on the positive x-axis, meaning OA is the initial side of the angle. So OA is the initial side of the angle theta. And OP, meaning this line, is the terminal side. Terminal side of the angle. So now we are going to consider the angles theta in various quadrants. So here is theta is in the first quadrant because the angle, the point P is lying in the first quadrant. Its coordinate is our x and y. So if we draw a line now from T down to this point, or we can quickly shorten this to make this point P on the xy plane, and this is R. R is a positive radius, so here is y, and here is x. So theta now is in the first quadrant because the line OP is in the first quadrant, and P is, if specifically, P is lying in the first quadrant. Now, if theta is in the second quadrant, so this is the initial side OA. OA is the initial side as usual, and theta lying in the second quadrant, meaning P is here, x comma y, and then this is theta. So here is x, here is y, and here is our x already on the negative x-axis. So this is in the second quadrant. This is how we view the picture of the coordinate. And looking at this, here is A, here is theta, and here is the point P, xy. And so what we have here is the negative y, and then theta is in the third quadrant. Similarly, we'll also look at theta in the fourth quadrant. Theta in the fourth quadrant. Here is A. Sorry, O is the center of the circle. And we see this is a point P in the fourth quadrant. So this is the point P. So this is radius. This is radius, positive radius. So this is R, while, okay. So here is our radius, and here is the negative y, while here is the positive x-axis, and this is theta. And so theta is in the fourth quadrant. So to check the trigonometric functions of all these angles, so we draw a right-angled triangle. And here is the y-axis, the x, while here is theta, and this is r. So that what we have, these are the triangles, or this is the triangle in these four diagrams, in the four quadrants. So that sine theta, so we see the 6 trigonometric functions of the angles in the four quadrants. What are the trigonometric functions? The sine, which we normally, the sine of theta, which we normally shorten it as sine theta. And then the cosine of theta, which we normally shorten it as cos theta. And then tan theta, which we normally shorten it, the tangent of theta, which we normally shorten it as tan theta. And then we have their reciprocals. So we have cosec, which we normally shorten it as CSC of theta. And then we have the sec. That's the secant of theta, which we normally shorten it as the sec theta. And then the cotangent of theta, which we normally shorten it as cot theta. So from the diagrams, one can quickly see that this diagram of a right angle triangle is representing all the triangle in the 4 quadrants. And so by this, we have sine theta is equals to the opposite side here. So here is the opposite side, and here is the hypotenuse side, and here is the adjacent side. So sine theta is equal to opposite side over hypotenuse. And that is equal to, that is equal to y over r. Also, we see cos theta. This is equals to opposite adjacent over hypotenuse. This is adjacent over the hypotenuse. And this is equals to x over r. Can also understand that tan theta is equals to, tan theta is opposite over adjacent, and that is equals to, so we write opposite over adjacent, and that is equals to, our opposite is y, and the adjacent is x. So likewise, the other 3 trigonometric functions are the reciprocals of the first 3 trigonometric functions we have. And so by this, we will see that the cosec, that is cosec theta, is equals to the reciprocal of sine theta, that is hypotenuse over the opposite. And that is equal to r over y. So the next trigonometric function is cosec. Is cosec theta. So sorry, sec theta. Sec theta is equals to the reciprocal of the reciprocal of cos theta, and that is equals to hypotenuse over adjacent, and that is equals to, so this is equals to 1 over sine theta, and this is equals to r over x, and that is equals to 1 over cos theta. It is the reciprocal of cos theta. And we see also that the cotangent, the cot theta, is equals to the reciprocal of tan, and that is adjacent. So adjacent over the opposite side. Adjacent over opposite, and that is equal to x over y, which is equals to 1 over tan theta. So these are the 6 basic trigonometric functions we have. So what are their relationships, especially with tan? We have seen that cot is 1 over tan. We have also seen that sec theta is 1 over cosine. Likewise, the cosec theta is 1 over sine theta. But what about tan theta now? So tan theta is equal to sine theta over cos theta. But what is sine theta? Sine theta is y over r. So we have y over r divided by, because this is the division line here, divided by cos theta, and this is x over r. And this is equal to y over r times r over x. So r will cancel r, and what we have is y over x, and that is equal to y over x, that is tan theta. So we see always when we have tan theta, we can represent it with sine theta over cos theta. Now let's go to the sign of these trigonometric functions. So these trigonometric functions can either be positive or negative, depending on depending on the quadrant theta is falling in. So or we say, okay, let P be a point in the xy plane and what r greater than 0 be a radius of the circle that is intersecting a point A on the xy plane, that is a point on the x-axis. So now let also OA be the initial side of the angle theta, also on the xy plane. So we will see that the 6 trigonometric functions will either be positive or negative depending on the position of P on the xy plane. That is, depending on where P is, in which quadrant P is falling on the xy plane. So that if we are in the first quadrant, and here is P, okay. If we are in the first quadrant, and here is P, so we see that the coordinates of P are both positive. That is, so first quadrant. So in the first quadrant, x and y X and Y axis are all positive, because here is X and here is Y. So the line AP is positive and the line OA is also positive. And theta is a positive angle in the anti-clockwise direction. So here we see that sine theta is equal to opposite over hypotenuse. So let me just use sine theta is opposite over hypotenuse, that is y over r. And then cos theta is equal to adjacent over hypotenuse, that is x over r. And then tan theta is equals to opposite over adjacent, that is y over x. Also, their respective reciprocals are, this is cosec theta and it is r over y, and this is sec theta, which is equal to r over x, and then the cot theta, this is x over y. So notice that all the angles in the first quadrant, for all angles in the first quadrant, their trigonometric ratios are all positive. So sine is positive, therefore cosec will also be positive. Cosine is positive, and therefore sec is positive, and tan is positive, and therefore cot will be positive. What we will notice is that if A over B is positive, then we will have B over A is also positive. So now let's look at theta in the second quadrant. So now the second quadrant. So now for theta in the second quadrant, here is OA. So theta is in the second quadrant, and therefore the point P will be here on the in the second quadrant, and here is theta. So here y is positive, but x is negative. So in this quadrant, x is negative and y is positive, we can see. So let x be equals to, say, minus n, and y be equals to m, where n and m are positive, are all positive. So I'll put x here to be minus n and y to be m. So y is equal to m here. So that sine theta is equals to opposite over hypotenuse. So that is y over r. And then cos theta will be equal to opposite adjacent over hypotenuse, but my adjacent is minus n, therefore minus n over r. So we see this is actually negative. So this is what I will do. So cos theta is equal to cos theta is adjacent over hypotenuse, that is minus n over r. Because n is negative, and so I will have minus n over r, and this is actually negative. This one is positive. So what about tan theta? So tan theta will be opposite over adjacent, and that is m. So let me put m here, because y is equal to m, even though it's the same. So here is m. So it will be opposite over adjacent, that is m over minus n, and that is equals to minus m over n, which means this is negative. So since the three are here, I don't have to talk about their reciprocals because of this statement. Once sine theta is positive here, we know cosec theta will also be positive. Because we have cos theta here negative, therefore sec theta will be negative. So tan theta here is negative, and therefore also cot theta will be negative. All right. So let's go to the angle in the third quadrant. Now for theta in the third quadrant, so we have the xy plane as usual. So so I have the circle on the xy plane, and theta is in the third quadrant, meaning the point P is here, and this is the angle theta in the third quadrant. But here in the third quadrant, x is negative. So let me take x to be negative, say minus n, and y is also negative because here is negative, and so I have minus m, and this is r. So as in the second quadrant, we let x to be equals to minus m, but here y to be equals to minus m, where n and m are all positive. Let x be equals to minus n and y to be equals to minus m, where where n and m are belonging to the positive sets. And so we will have sine theta here to be equal to opposite, okay, sine theta will be opposite over hypotenuse, and that is minus n over minus n over r. And that is actually minus n over r, and that is negative. So cos theta will be equals to, cos is adjacent over hypotenuse, that is minus m over r, and that is equals to minus m over r. This is actually negative. We have tan theta to be equal to opposite over adjacent. The opposite is minus n, and the adjacent is minus m, and that is equals to n over m, because negative over negative, the answer will be positive, and therefore it's a positive angle. So let's finally look at theta in the fourth quadrant. So for theta in the fourth quadrant, for the fourth quadrant, now for theta in the fourth quadrant, we will have the point here in the fourth quadrant, P. And this is the angle. And therefore, so I have to put an arrow here. And we see that y is negative in this quadrant. So say minus m. But x is positive. Give it m. So give it n. Or you just write x. There is no problem. And here is the radius of the circle. Here we will have sine theta to be minus m over r. That is opposite over hypotenuse, and that is equals to minus m over r, meaning theta is negative. Also, we will have cos theta to be equals to adjacent over hypotenuse. But the adjacent is n, hypotenuse is r, so this is equals to n over r, and that is actually positive because all positive. So we have tan theta. Tan theta is opposite over adjacent, and that is minus m over n, and that is equals to minus m over n. But this is negative. And so we will have something like this. So we have the four quadrants. We will have the four quadrants here. So here is the first quadrant, everything is positive. Here is the fourth quadrant, where only cosine is positive. If we notice, cosine is positive while all the rest are negative. And here is only tan is positive, if we can remember. So, and here is only sine in the first quadrant is positive. So that if we have the four quadrants, so that you have sine theta, this is always positive. Cos theta here is negative, and then tan theta here is negative. Here sine theta is positive, cos theta is always positive, and then tan theta is always positive. In the third quadrant, sine theta is negative, Cos theta is also negative. Tan theta is the only positive function in the third quadrant. While in the fourth quadrant, we have sine is negative, sine theta is negative, cos theta is positive, and then tan theta is negative. So here only cosine is positive. Likewise, their respective reciprocals are also behaving in this way. So you can easily remove this. You can replace sine with cosec, and the sign remain the same. Thank you for watching our video. Please endeavor to like and subscribe for more videos.